How's everybody doing? Good, yeah, DerbyCon, awesome. So I'm nyxgeek. I'm going to talk today a little bit about hacking Microsoft Lync, or Skype for Business as it's now called. I guess first the obligatory, who am I? I'm a pen tester for TrustedSec, general security enthusiast. It's my first time here. It's been a blast so far. And I'm going to be, full disclosure, I'm not like an admin. I don't set up Lync. I'm not an architect. I'm not a pro at the back-end configuration of it, but what I am going to do is I'm going to show you a little bit about the things that I found that you can use to attack it. So let's take a look here quick and see what the Lync setup is like. In order to do this, I use the test drive from Microsoft. You can download it. It's a little bit old. You'll have to renew your certs in it if you're going to use it. But you need 4 VMs, 16 gigs of RAM minimum, so it's a little bit hefty. But yeah, 4 machines running. The only important machines are the Lync server front end, the domain controller, the Exchange server, and then the web app server. So you need those 4 in order to set up a working Lync test drive. So in this, I'm going to take you through an attack overview. First, we're going to look at locating the Lync servers. They're pretty easy to find. Then we're going to go through domain enumeration, user enumeration, and then the things you can do once you've found those pieces of the puzzle. So the first thing to do is to locate them. Linkdiscover.whateverdomain.com. You can scan the internet for these. It'll actually point you to the real Lync server that's doing the Lync front-end server. So in this case, you can see here, it's the 2013 link-fe.contoso.com, Microsoft's fake domain. So that's where actually all the fun stuff is. Find this and it points you to where the goodies are. On that front-end server, there's 2 main areas that are kind of interesting. One is the dial-in page, and then the other is the scheduler page. And they're just interesting because they're single-factor sign-on, and they allow you to actually reach in and touch AD accounts. So looking at this a little bit closer, this is what you'll see. I just have in this I just had a host set up in my etc. host file, so you won't be able to go to that URL, obviously. But you click the sign-in button, you get another page where they ask for a domain username and then a password. And then here's the scheduler one. That's what that one looks like. Now, both of these, when you go to log in, just post an XML doc up there. This is a cleaned up version, so you can see there's a couple areas here I want to focus on. One is the username token. You can see that's just base64 encoded. It's without a new line, and it's domain/username. So you can do an echo, to get that. And then you can also see they actually have in here a created time and an expires time. But spoiler alert, they don't do anything, or at least not in my experience. You can still attack with it. You don't need to update that at all, so just forget about it. It's there, but it's, I don't know why. Another thing that's kind of interesting about this Lync front-end server is that there's a number of NTLM auth prompts that you can get to. So these are great for brute forcing against. So there's one at the web ticket service, and then there's one under the address book synchronization folder. I don't think that you can deny access to the web ticket service because that's what that post goes to. So unless you're not going to use dial-in and scheduler, you have to have that exposed. As far as I know, you can't do anything about it except for to disable NTLM off and go cert-based. So during my scans of the internet, I looked at the Fortune 1000 list from 2015. 52% had DNS entries for Lync Discover. Not all of them were actively pointing to something really. So in the end, about 48% had dial-in page exposed and 42 had the NTLM auth that you could get to. In the Alexa 1 million, it drops down, but that makes sense, right? Because who's running Lync? Big companies. So yeah. So next, we're going to move on to domain enumeration. It's super simple, easy with this. Nmap to the rescue here. You can just run an Nmap script for the HTTP NTLM info. And that'll give you the internal domain name. So even if it's not if it's not obvious from the external world, like if it's not contoso.com, if it was contoso internal or something, it wouldn't matter, it would show up there. So you need that for the login. So now let's look at user enumeration here. There's a standard, the OSN, right? You do a site search on Google for a site, contoso.com, file type PDF, and you scrape the metadata out of that. Oftentimes, companies will have usernames in that metadata that you can use, at least to figure out what kind of format they're using, whether it's, first initial, last name, last initial, whatever. That's an easy way to kind of get an idea. But there's also a timing attack that you can do against those 2 web pages that'll reveal the real usernames for you. So you submit the post request, and if it's a valid username, you'll get a really short response. If it's an invalid one, it'll take considerably longer. So covered this. Yeah, you can only single thread it, it seems. So here's a bash script where I just did curl, right? And I timed my curl. So you can see here is with the valid username, it was about half a second, and an invalid took like 4.5 seconds. So it also seems to depend on the size of the domain, how many users there are. Not 100% on that, but it definitely seems to be that the larger the company, the bigger the time lapse that you see between the two. And you can only single thread it. I noticed if you try doing multiple threads there, the timing gets skewed kind of. It's not as clean. You can't see it as easily which accounts are valid and which aren't. So I'd recommend just try to find kind of the base pattern and then generate some off of that and use that to run through and find the valid ones that way. So I did tell Microsoft about this back in June, and they're like, oh, thanks. They got back to me within 24 hours telling me that they did not care at all. So, I mean, it's not like a remote code execution or anything, but it doesn't have to be there, I guess, is the thing. They could add a random timer into that and fix it. So you can do the timing attack with Burp Suite. It's not as reliable as doing it another way, which is with Python or the bash script, but it's easy. It's got a GUI. Right, I mean, so add a prefix and then base64 encode, but, oh, and also make sure you drop out that payload encoding, because that will screw you with the base64. So here's just an example. I'm going to be putting up the Python code for this. It's really simple, though. All you're doing is submitting that request, right? So if you can write Python, you can write a post it'll take a username list, encode it, and in this you can see here, so try guessing which ones were the valid ones based off of the short timing being valid, right? So I just did the word Alex because they have a number of Alexes in that built-in domain, or in that built-in test drive. So you can see here we got an Alex D, we've got an Alex S, and then an Alex W. So those are all valid where the other ones are not. So now what? We know the domain name, we've got usernames. We got a couple of places we can try these out. So what do we want to do with those? There's a couple things that you can do with it. There's the lockouts and brute force attacks, which is what we're going to be looking at here. Account lockouts. So it's kind of lame, right? I mean, it's a DOS attack, but so first of all, because you can hit any account that exists, you can't restrict it to OU. We contacted Microsoft about it, and their response, at least to us, was we basically have to rewrite the product in order to do that. And I'm not sure how that works. I don't know how they wrote it that it's like that, but you can hit administrator accounts, you can hit any service accounts, anybody's accounts that you can find. You can lock them out, you can attack them, you can do whatever with them. It's fun. So a few questions to think about, right? In your environment, do you have separate admin accounts from your regular user accounts? I mean, do they unlock automatically after some time? Or if I'm a jerk and I run through and I lock out all your accounts, are you all locked out for real, forever? So yeah, those are some things to think about here with this being exposed externally. What could people really do if they wanted to be a jerk to you? So the other thing that I would recommend doing, do a brute force attack against them, right? You can go wide against all usernames, the traditional summer 2016, fall 2016, whatever, company name one, bang. And you can use Burp Suite for this, or you can use Medusa against the NTLM off page directories. Medusa is pretty fast, and Burp is fine. You just look for the 200s. And I've tested it with that expiration time. I waited 12 hours and I replayed it again. Same thing, you get the 200s on the valid username passwords, and you get the 500s if it's invalid. So yeah, that token, I'm not sure why they even included the expiration date in there. So if we're going to set up the brute force with the Burp Suite, yeah, the timing doesn't matter. Just remember to do this. Do the prefix contoso and then the base64 encode, and then take off the payload encoding there, or else it won't work properly. I was banging my head against the wall while I was trying to do this. I'm like, I know this works. Like, what's wrong here? Oh, right. My equal signs are getting encoded to 3D. Okay, great. So remember to do that. Here's kind of just an example quick. This is what you'll see when you actually do a burp attack with it. Yeah, you get the 200s, a different response length, of course, versus the 500s that have the shorter length of the file. All right, so next we're going to take a look at Medusa. Hopefully you can read that in the back. I know it's kind of small. I'm going to run you through just a live demo of it quick in a bit here. But so you can see it works fine. You just with this we're just using a user list. It just was my a group of names, and then summer 2016 set the module to HTTP and specify SSL, right? And then just set the directory to the ABS or the web service ticket directory. So far we've taken a look at, we found the internal domain, we found usernames, and then we've been able to attack some of them. So what do we do now? I mean, now that we have these things, what can we do here? So one of my favorite things to do is when you're on a pen test and you find some usernames like this, you don't necessarily know who the usernames belong to, right? You might either be a number or it might be a first name, last name, but you can't really figure out who they are. So one of my favorite things to do then is to go to LinkedIn, right? Sorry, I skipped a step here. First, we're gonna log into that dial-in page that we saw, and it'll actually show you the guy's username there, his real name, I mean. And you don't need to do anything here. You can just cancel out of that and you're fine, but you then have a person's real name that you can go to LinkedIn, see, oh, are they an IT director? Who is this? Is it a worthwhile account to use, or should I move on to the next person? Should I keep going? So that's a fun thing to go through and do. Let's see, what else can we do here? Single factor login pages, if you can find like their company intranet page, OWA, or if you're close by them, you might be able to get on their wireless with these credentials that you got from Lync. So I mean, there's plenty that you can do with it. Now at this point, I think we're just gonna run and jump into. See here if I can. Just bear with me for a moment. Cool. All right. Am I on right now? Session might have died. All right. So first we're just going to show finding the domain. I just wrote these into a bash script so it'll be easy to run through here, but it'll show you the command that's run. So we're running the command nmap with the script, and we can see it indeed returns this. So this is actually a server that's being hosted out of my apartment, sitting in our closet. It's a 1U server that we did some port forwarding to. So, and then I added host name into my etc. host file just so we can poke at it this way. So there's that right there. Let's look at. This one should be. So what this Python script is doing is just taking a username list, right? And this is the same one I showed you a screenshot of, but in real time, so you can kind of see. Something that you might want to do is to send it a fake name first, see kind of what a baseline is that you have for what the invalid usernames are, and then from there you can figure, okay, half of that or less is going to be a valid username. It's usually around, it's almost certainly under half of the invalid response time. So that's something to be aware of. You could probably do some cool maths there and figure out kind of what would be a good way to filter between them. I've just been using, looking at it, saying, okay, let's look through here. Where's the pattern? Because people are really good at detecting patterns. Computers sometimes aren't, unless you tell it how to do it correctly. So, I mean, it's not the most efficient way necessarily, but it definitely works. And then from here, let's look at. So here we're just going to run Medusa against it, and it's quick. It runs through. You're going to find it in the bigger environments. You're definitely going to find multiple people that have these bad passwords. I mean, it's how it goes. They're predictable. They choose things. Oh, I have to reset this every 90 days. They're going to choose ones that are cyclical in nature, or otherwise easy to guess that way. So I mean, the one thing you do have to worry about is locking out accounts, right? So I was testing at one place that I used to work, and I was running this overnight, looking for some weak passwords, and I completely forgot about our offshore resources, and I might have locked out a few hundred people for around 20 minutes. So be careful, right? Be aware that these are in fact hitting 80. They are counting against the lockout, so just be careful if you're experimenting in your office or anywhere, because you might ruffle a few feathers by doing it. And then, let's see here. Kind of weird doing this way. All right. Sorry about this. We're just going to run this with just one username in here. And all it's going to do is it's going to run it 5 times just to kind of show you that you can indeed lock out accounts here. Is that right? Oh, bummer. So let's do this manually instead. It'll be just as easy. All right, so if you go to the base directory here on any of these Lync servers, you'll just get the standard 403 forbidden here. So here's the ABS page here. You'll get the NTLM prompt or auth prompt there. We can just contoso/administrator. Be a fun one. We'll see if we can. So we'll just type in a fake password there. Give it a few times. I think I have this one set to do it after 5. So. Or this should be enough there. Okay, let's pop over here. I've got an RDP session open, and we'll just do a search for the locked out accounts here. If I did it right, good. Yeah, you can see the administrator account is locked out. So, and if you haven't renamed the administrator account, that's a prime target if somebody just wants to be mischievous and mess with your company, right? Like, also, yeah, going back to that. Domain admin accounts, if you're using a certain naming convention and they can figure out what the naming convention is, it might be a bummer to come in one day and find that all your DA accounts are locked out. Or service accounts, like if you have things that run on, let's say, batch processing at night, things that run at nighttime that are very critical, and you can discover those usernames. So make those long if you can, I guess, is the best advice I can give you there, because you can brute force. I did some sampling, and it would take about 140 days, I think, to realistically cover up to 8 characters brute forcing. So anything under 8, I would say, is probably not safe from being discovered via a brute force attack. So yeah, the things to consider if you're running Lync on your network. So let's go back here. All right, so we've covered this. Talking about protecting it a little bit. What can you do? You can configure 2-factor on there. I am of the opinion that you should just require VPN to access it. I know it's not going to fly everywhere, because part of the dial-in and the scheduler is that you can to talk with other companies. You can have external people jump in with you. You can disable the NTLM auth. That's kind of an issue because you need somebody to be there in person first, as far as I understand. And like I said, I'm not an admin for Lync, but this is what I found as far as what seems to be the most reliable way to solve it, is to disable the NTLM auth. That'll save you a lot of hassle there. Or really put a WAF in front. If you can at all, restrict connection attempts by IP. That'll really throw somebody for a loop if they're trying to mess with you. You could spin up like an Amazon botnet, I guess. That would be one way to get around this. If you wanted to hit it from multiple IPs, but your normal run-of-the-mill person isn't going to go through the effort, I think, to attack it from multiple IPs. So those are some ways that you can actually protect it. I guess this is a small enough room. Does anybody have any questions that I can tell you about? Does anybody have any questions on the attack surface? Yeah. So I haven't actually looked at the Office 365 that much, so I can't really speak to that. So I'm sorry. Any other questions? All right. Oh, yeah.
Did you compare this to the Skype for business?
Well, so are you talking about like the Skype for Business? That's the Lync got renamed, right?
Right.
I haven't tried it against 2015, if that's what you're wondering.
Yeah.
So that's something that would be fun to test out. I didn't see a test drive or anything for it yet, and I don't really have the means to set all this up on my own. So. Yeah, it's something to definitely look at, though. Hopefully they do fix some of these things, especially the OU one. I think is ridiculous that you can reach out and touch anything in the AV environment, any account that exists. So, but yeah, oh yeah.
Have you played with the bastardized X7PP service part of this?
I have not. This is everything I've done here has just been revolving around, from kind of the web side of things, pen tester side, but I'm not into SIP really or any of the XMPP stuff. Like, yeah, it's outside my ballpark stuff. But so, I guess, yeah, if we just want to look at the problems that there are with Lync here, yeah, we can remotely lock out accounts. You can't restrict those login attempts to any specific OUs. We got multiple web forms that don't implement any type of authorization tokens, any cross-site request forgery tokens that might help stop Burp Intruder from just slamming away at it. Then they don't look at the timestamps that are in there. So I mean, I would say it's poorly implemented. And then the directories that are exposed that you can just hammer on with Medusa, also a problem. And then of course the user enumeration timing attacks that you can do there. So I think that if you're looking at opening up Lync to the outside world, I mean, a lot of people do it. There's around 50% of the organizations in the top 1,000, Fortune 1000 do this. But if you're thinking about doing that, you know, these are all things to consider with that. And kind of moved through here faster than I was anticipating, so I apologize for that. But so with that, yeah, Skype for Business, you are the weakest link. So yeah, thanks. Goodbye. If anybody wants to talk afterwards.